shell sorting?
How does it work?
Why do you prefer shell sorting? Those are the questions we're going to answer in this video. But before that, let's hit it on the intro.
Today, I want to talk about shell sorting because many of you have been confused about shell sorting and how it works. Shell sorting, also known as shell sort or diminishing increment sort, is an efficient and adaptive sorting algorithm. It was introduced by Donald L. Shell in 1959 and is an improvement over simpler sorting algorithm like insertion sort. Shell sort works by sorting sublist of elements separated by a certain gap or interval, gradually reducing the gap size until the entire list is sorted. This technique makes it faster than insertion sort, especially for larger lists.
Hi, my name is Sherry and I'm going to further discuss how shell sorting works. Let's assume that this line of people here in this video we are going to provide are the numbers of the sublist we need to sort. But first, remember that the key idea behind shell sort is to use a sequence of gap, also called increment, to control the order in which elements are compared and swapped. So now, let's play the video. This performance shows 5 gap. Okay, so what happened is to take out the first element, which is 3, and the 6th number or the 6th element, which is 2, to compare and swap if necessary within the respective sub-array. So as you can see, 3 is greater than 2, therefore the elements should swap in their places. So what happened next is you take the second element, which is 0, with the implementation of 5 gaps. Therefore, the 7 element, which is 5, is taken out, but as you can see, 0 is less than 5, therefore they should remain in place. And you just basically repeat the whole process by taking the next element out and the implementation of 5 gaps, and then the next element shall be taken out and compare and swap if necessary. So basically, as you can see on the video, they're basically dancing happily as they may switch in place. Now let me just pause the video here. As you can see on the performance, only 3 people are facing backward, which indicates that the gap value now is 3. Since in shell sorting, remember that the gap value should gradually decrease, and repeat the insertion sort process on the sublist with the new gap array. And the process will continue until the gap value becomes 1. Okay, now let me just continue the video. The process is still the same. However, the gap value is now 3, which you just have to take out the first element with the implementation of a new value and take out the next element and compare it and swap if necessary. And again, let me just pause the video here. So as you notice, after the 4th element and the 7th elements being compared and swapped, the 4th element automatically compared the first element. Why? Because the new gap value is applicable to the 1st and 4th element, okay? So now they are being compared and swapped if necessary.
We apologize for some technical problem that happens here. Unfortunately, the camera stopped recording and we only notice it while editing. But I'm still going to continue explaining this part of the performance with my voice only, and I hope you understand. Basically, the process continues with the implementation of the gap value, and they also automatically compare the elements to the left and swap if necessary. And as you can see, the sublists now are slowly sorting, but not that quite obvious until the gap size becomes 1.
Now, only one person remains facing backwards, which indicates that the gap value now is 1. We just need to repeat the whole process with the implementation of a new gap value. But remember, we can apply the gap value backward as long as it is applicable or suitable, okay? The last pass of shell sort is performed with a gap size 1, which we now effectively turning the algorithm into a standard insertion sort. And since the elements are now very close to their correct position, this pass is efficient and requires minimal comparison and swaps. And finally, after the final pass with a gap size of 1, the entire list now is sorted in ascending order. So as you may see on the video, that they are dancing happily as they are already sorted.
Shell sort's performance depends on the choice of the gap sequence. While it's faster, the insertion sorts performs well in practice. Its time complexity is not as well understood as some other sorting algorithms. In practice, it often outperforms algorithms like double sort, insertion sort, selection sort for moderately sized lists. So the main advantages of shell sorts are its adaptability and improved performance compared to a simple quadratic time sorting algorithms. However, it's not as fast as more advanced sorting algorithms like quicksort or merge sort on a large data sets. The choice of a gap sequence and its impact on performance remains an active area of our research. And there are variation and optimization of a shell sort designed for specific use cases.